Okay, this is Algebra 2, Section 5.1, Properties of Exponents. The first property we're going to look at is the product property. That is when you have a base to a power times the same base to a different power. To simplify that, the base stays the same and the powers are added together. So this example is 2 to the 7th. You can kind of think of it the long way, like 2 to the 3rd would be 2 times 2 times 2, and then 2 to the 4th would be 2 times 2 times 2 times 2, so altogether we have 7 of them, and that's why it's 2 to the 7th. The next one's the quotient property. If I have a to the power of m divided by a to the power of n, then we will subtract those powers. So in this example, that would be 5 to the 4th. And again, we can think of it the long way. If I have 5 times 5, 6 of them on the top, and then 5 times 5, 4 of them, sorry, 2 of them on the bottom. This one cancels with this one cancels with this one, and that's why I have 4 left over. The next one is negative exponents. A to the negative n is the same as 1 over a to the positive n. When we have a negative exponent, it tells us to flip the item, and so when we flip a, it becomes 1 over a, because any number can be written over 1 and it doesn't change its value. So this one would be 1/4, and then the 3 would turn to positive. This one would be 7/2, and then the 4 would turn to positive. This one we have to be careful to make sure we're keeping the parentheses, though otherwise it changes its value. The next property is zero exponents. A to the power of 0 is 1. 7 to the power of 0 is 1. 12 to the power of 0 is 1. Anything to the power of 0 is 1. Then we have power of a power. When we have a base to a power to another power, we multiply the exponents. So this example would be 2 to the power of 12. I'm not going to write out a bunch of 2's, but let's just pretend they're 2's. 2 times 2 times 2 would be 2 to the 3rd. And then 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2. I have 4 groups of those, that's what this 4 means, and so altogether there would be 12 of them, which is why we have power of 12. Next we have power of a product. So this is a times b, quantity, to the power of m. So that would be a to the power of m, b to the power of m. The exponent gets put onto both the pieces in the parentheses. Even if there were like 3 or 4 things in there, the exponent goes to every item in the parentheses, not just the last item. That's probably one of the #1 things that I see wrong on the tests. So again, it's 7 to the 3rd, x to the 3rd, not 7x third. Moving down. I have power of a quotient. Again, we need to distribute that exponent, so it would be a to the m over b to the m. So this example would be 2 to the 4th over 7 to the 4th. Backside we have some examples. I'll write without exponents. When I have a negative power, it tells me that I need the reciprocal, so I'm going to flip it. Now to simplify it even further, I can do 6 to the 3rd on the calculator. 6 times 6 times 6 is 216. So my answer is 1 over 216. Letter B, I would just do -6 times -6 times -6, -6 to the 3rd, which would be negative 216. Now be careful, when you do something to an odd power, the negative sign remains, but when you do something to an even power, the negative sign actually goes away. If I had just done -6 times -6, or negative 6 squared, that would have been positive 36 because a negative times a negative turns positive. The last one, I have 2/3 to the power of negative 2. So because the exponent's negative, I need to flip it. And now to get rid of the parentheses, I need to square both numbers. And that is my answer. Example B, rewrite in the form x to the power of n. When I have the same base, I add the exponents, so this is x to the 8. When I have the same base on a quotient, I subtract the exponents. 11 minus 5 is 6. When I have a power to a power, I multiply the exponents, so that is 12. I'm going to scroll down for the next bunch. Rewrite in the form a times x to the power of n. So when I'm multiplying these two expressions, the coefficients I treat normal. I want to do 5 times 4, which is 20. Now the x2 times x4, I'm going to add the exponents, so that'll be x6. Part B, these I'm going to treat like normal. 12 divided by 3 is 4. And the exponents we subtract, so that is x to the 3. This one's going to be two parts. First, I need to distribute the powers into the products. So we'll do 2 to the power of 3, which is 8, x to the power of 3, 3 to the power of 4, which is 81, x to the power of 2 to the power of 4, those get multiplied, so that is to the power of 8. Now I would do 8 times 81 to get 648, and the exponents get added together, so that will be x to the 11th. And we are almost done. To do the last bunch, we are going to again just distribute the exponent. So this will be 81 to the power of 3/4. Now if you're just typing these on the calculator, you need to put parentheses around the power, otherwise the order of operations comes out incorrectly. So 81 to the power of 3/4 is 27. If you're working with a calculator that has powers but doesn't have parentheses, then you're going to need to turn your fraction into a decimal and do like 81 to the power of 0.75, and it would give you the same answer. So then for the exponents, again, we're going to multiply them together. 8 times 3/4 is 6, so this will be 27, x to the 6. Over here I need to do 216 to the power of 2/3, and that is 36. And on my powers, I multiply the exponents. 12 times 2/3, and that is 8. And that does it for the examples. The exercises follow, and it is the rest of this page and the front of the next page. Good luck!